Explicit linear Runge Kutta methods. Today we will discuss Runge Kutta methods in fourth order. Runge Kutta methods are a family of numerical methods used to approximate solutions of ordinary differential equations. This is a short form ODE. The general form of an ordinary differential equation is dy upon dx equal to f of x comma y x naught equal to y naught. It means initial condition we will start. Runge-Kutta methods improve accuracy compared to Euler's method without requiring higher order derivatives. The general form of an explicit Runge-Kutta method. General explicit Runge-Kutta method of order is given by. Now you can see here this is a general form of Runge-Kutta method where we find Ki means K1, K2, K3 continuous. This is a general form of Runge-Kutta method. Now you know Aij, Bi and Ci are coefficients is in these equations. Euler's method first order Runge-Kutta RK1. This is a short form RK1. This is the simplest Runge-Kutta method equivalent to RK1. Formula yn plus का 1 equal to yn plus का h f of xn comma yn. Second order Runge-Kutta methods. This is a short form RK2. Midpoints method. This is a name also. It is a midpoint method. This method uses the slope at the midpoint. K1 equal to f of xn yn. You know, if we will start initial value, then we put n equal to 0. It means x naught. And n equal to 0. It means y naught. Same process K2 we will find n by n plus ka 1. The formula is given. Now you can see here Heron's method. Import Euler's method RK2. This is a short form RK2. First we find K1. The formula is given f of xn comma yn. The K2 f of xn plus का h comma yn plus का h K1. Now you can see here if we find the value of K1 then we put these values of K1. Now if we get K2 then we put this in K2. This is a value of yn plus का 1 equal to yn plus h upon 2 k1 plus k2. You must know if we find y1, it means we put n equal to 0 in all these. N equal to 0, n equal to 0, n equal to 0. It means x naught we get y naught according to same process. Continues, we will find the answer. Classical fourth order Runge Kutta methods. Short form is RK4. This is the most commonly used explicit Runge Kutta method due to its balance between accuracy and efficiency. Now formula we will start. A1 equal to f of xn comma yn. A2 equal to f of xn plus का h upon 2 comma yn plus का h upon 2 k1. Now you can see here, if we find k1, then we put these values in k1. Now here is given k3. Same function f of x n plus का h upon 2 plus का yn plus का h upon 2. Now we put k2 because first we find k1, then we put these values of k1. If we find the value of k2, then we put these values of k2. Same process. Therefore, we will find equal to f of xn plus h comma yn plus का h k3 because we have find k3, then we put these values of k3. After the find values of k1, k2, k3, k4, all values we will put in these values. Now you can see here yn plus का 1 equal to yn plus का h upon 6 k1, which we have find the value of k1 plus 2, the formula value of 2 k2, which find the value of k2, we put this plus का 2, the formula value of 2 k3, these values of k3 plus का k4. After these values put in, we will get y1. If we will find y2, then again we put this n equal to 1 and n equal to 1. Same process we will start k1, k2, k3 and k4. Then we get y2. If we find y3, all functions we will follow k1, k2, k3, k4. Then we find y3, y4, y5, y6, which required accuracy. Now we will solve questions. Solving an ODE, ordinary differential equation using RK4 means Runge Kutta method in fourth order. Or means fourth order. dy upon dx, the first derivative equal to x plus ka y. This is a function is given y0 equal to 1. The initial value of x not equal to 0 and y not equal to 1. For x equal to 0.1, using h equal to 0.1 n or k4. This is initial questions is given. Now we will solve these questions. Now you can see here, first step, compute A1, A2, A3, A4, which you know how can we find. Now the formula of K1 is given, K1 equal to f of xn, comma yn. You know, if we find K1 first initial value, you know the put n equal to 0. It means x naught. The x naught value is given, x naught equal to 0. We put these values, x naught equal to 0, comma n equal to 0, it means y naught. These values, y naught equal to 1. In the questions is given x naught equal to 0 and y naught equal to 1. Now we put these values in functions x plus ka y. You know the value of x is 0 plus ka y. The value of y is 1. 0 plus ka 1 equal to 1. Now after k1, then we find k2. The formula of k2 is given. You can see here k2 equal to f of x naught. You know x naught, the value of x naught equal to 0 plus h. The value of h is 0.1 divided by 2. According to this formula, if 0.1 divided by 2, we get 0.05 and x naught is 0. When we simplify, then final answer we will get 0.05. Now you can see here comma is given, then you write comma y naught. You know the value of y naught is given 1 and plus sign is given, then you write same plus sign. H upon 2, you know the value of h is 0.1 divided by 2. 0.1 divided by 2, then we will get 0.05 k1, which we get the value of k1. What is k1? K1 equal to 1, then we put these values, k1 is 1. Now you can see here, first we simplify, 0.05 is given functions, then we simplify these values, 0.05 multiplied by 1, then we add 1, we get 1.05. This is value of x and value of y. You know the function is given x plus ka y. It means the value of x is 0.05. We put these values according to questions, plus sign is given, the value of y is given, then we add both values, then we get 1.1. Now we will find k3. This is the formula of find k3. k3 equal to, you know x naught, the value of x naught equal to 0 plus the value of h equal to 0.1 divide by 2. 0.1 divide by 2, then we will get 0.05. Comma is given, you write comma y naught. The value of y naught is also given in our questions, then we put these values, 1 plus sign is given, then we put this plus sign, h upon 2. It means 0.1 divided by 2, we get 0.05. K2, which we have find the value of K2 before K3, we have get the answer K2. The answer of K2 is 1.1 is given. Then you can see here 0.05, you write same. Then comma is given. After the comma, we simplify these values. Solve these values. First you multiply 0.05 multiply by 1.1. Then we add 1. Then we get final answer 1.055. Now this is the value of x, comma, this is the value of y. Now according to questions, the questions is given x plus ka y. Then we put these values x plus the value we get y. Then we add both values. Then final answer you can see equal to 1.105. This is the answer of K3. After K3, we will find K4 because this is the fourth order of ordinary differential equations questions. You can see here the K4 formula. X naught, you know x naught, the value of x naught is 0 plus h. The value of h is 0.1. 0 plus ka 0.1 you write here, only we get 0.1. Comma is given, you write comma. The value of y naught is 1 is given in our questions. Plus sign is given, then you write plus sign. H. The value of h is given 0.1. You can see here h multiplied by k3. Multiply sign we will write. The value of K3, what we get? You can see here the K3 value we have find 1.105. Then put the values of K3 1.105. Then we simplify these values. You know 0.01 you write same. Comma is given, you write comma. After these values we simplify 0.1 multiplied by 1.105 plus 8. Then you get 1.1105. This is the value of x, comma, the value of y. According to questions x plus y, we will add both values. Then we get final answer 1.2105. This is the value of K4. Step 2. Compute Y1. Because we have get values of K1, K2, K3, K4. This is the formula of Yn plus K1. If we find Y1, then we put n equal to 0. N equal to 0, it means 0 plus ka 1, then y1 equal to sign we write same. If we put n equal to 0, then you can see here y naught. The y naught value is given in our questions, then we put these values is 1. Plus sign is given, then you write plus sign. H. The value of h is also given 0.1 divide by 6. This is the formula value of yn plus ka 1. This is a fixed value of 6. You write in every equation 6. Then you write 6, comma. Now you can see here K1, which we get the answer before K1. These values, plus sign is a formula value, plus sign according to formula is given, then you write 2. These values of K2, which we find 1 plus 1, then plus sign 2 is given in a formula. The value of K3, 1.105 we get, plus sign is you write plus sign. K4, 1.105, 1.2105. Then we simplify. You can see here 1 you write same, plus sign is red, 2 multiply by 1.1, then we get 2.2. Now we multiply by 2, 1.105, then we get 2.21. Plus sign is given and same value is given. Then we add all values. We get 6.6205. Now you can simplify these values, then we get 0.11034. Now we add 1.1103. Thus y 0.1 approximate 1.1103. We get this answer. Comparison of methods. Now you can see here, if we use Euler's method or K1, then the value of this 1.1 is we get. If we use midpoint method, means RK2, then we get 1.11. If we find Jones method RK2, then we get 1.11. RK4, fourth order, we use, then we get 1.1103. You solve all method 1, 2, 3, 4, and you compare the answer which is the best answer. Observations. Euler's method RK1 has the lowest accuracy. RK2 methods midpoint and ions give better accuracy. RK4 is significantly more accurate than Euler's method while still being computationally efficient. Thank you.